to approach this a little bit differently. I'm not going to approach it like a block of material that I'm cutting out. This would actually be done on some sort of lathe or a CNC mill that actually has a revolve rotation. So I'm going to be using the revolve command in my CAD or my Onshape to make this. So what a revolve does is it takes a profile and sweeps it around a center axis at whatever degree. This is obviously going around a 360. So I'm going to ignore these flat areas in the back here and on the front and the holes for now and just make this cylindrical piece. To understand what we're looking at, all of our, if this is our front view looking at it from this direction, I'm going to think of the widths from left to right. Those dimensions are pretty obvious. However, the heights are given to me in diameters. So the diameter of this cylinder, 26. The diameter of this larger cylinder in the middle, 60. This notation right here, that is saying there are 4 holes that are 6 millimeters in diameter that go all the way through this mass. They're evenly spaced on a diameter that's 46. So I know that these 4 circles are 6 millimeters. They're evenly spaced on a 46 degree or 46 millimeter orbit. Then I can come down. Each of these are basically another cylinder. And this long one is 12. This gap is 2. There's a small chamfer right on this front top corner, meaning instead of a fillet, it has an angled treatment that is 1 millimeter by 45 degrees. And the saw kerf is going right through here. Saw kerf is basically the thickness of the cutting tool. So we'll be referencing this one quite a bit. There's a couple other things like these flat areas in the back, 6 millimeters down. There is a hole here that is 6 millimeters, and this is a depth symbol that goes down 14. So this is a blind hole. It doesn't go all the way through, or else it should be notated like this. So I'm going to sketch this thing as if I were to see it from the front view, but I'm only going to draw from the center up, and I'm going to ignore the flat surfaces. So from the center up, it's going to look like a rectangle. From this center line, I'll do a really ugly sketch here. We're going to see a long spindle that comes up at an angle, comes over, comes down, comes over, comes up, comes over, comes up a lot, and then comes back. And again, we're going to ignore these little flat areas, but it would look something like that from the side. And that's what I'm going to start sketching. So I know the overall width is 170 millimeters. So let's start our file. Where's this one? 550. We need to change our unit of measurement to millimeters. And I'm going to be sketching on my front plane. I'm going to just start with a line right on the origin, and I'm going to make it at 170 millimeters. So I'm going to dimension that ahead of time so I can start sketching to proportions, or start sketching proportionately. Okay. So if I were to rough sketch this out, I'm going to avoid making things parallel if I don't know they are, because that just means I have to get rid of constraints later, so I don't know if these are perfectly aligned at angles. Alright, we'll see how wrong I was once we start dimensioning. So let's go ahead and throw in some widths before we deal with the diameters. I'm going to ignore the flat area, so this cylinder looks like it's 54 from the edge to where this large tall one starts. So 54, 12, we'll start with those two. And then it looks like this one is 13, This one's 9, and this one's 8. The 30 and 15 reference, you kind of have to follow the extension line down to the center axes. The 30 is all of these added together, and they're in parentheses. That's a nominal dimension, or that's it's an over dimension. So the 15 encompasses, yeah, so it's just the angle. All right, so let's get these three. 13, 9, 8. Then I'm going to dimension the point of this because it said it was 15. Notice if I just slide over, it's not the length of the angle, which would be a hypotenuse. It's from this point to that point. So that's going to be the 15. And then the 50 is really from this area over. So when we add the flat spot, we know it's 50. This saw curve notch is 32. So I think those are the widths we need for now. Let's go ahead and start to add in the heights, which are going to be half the diameter because we're doing from the center axis up. So it's a radius. So half of 26 is going to be 13. So I'm going to dimension from here to my center line, which is the radius. So 26 divided by 2. Then the tall one, I'll just leave the dimensions right inside the model. It's half of 60, so 30. Now, before I do this one, I'm going to throw in this smaller one so it doesn't go crazy on me. The small one, following the extension out, is 22. Actually, sorry, it's half of that, so it's 11. And this one is going to be 26, and so is the other one. So half of 26, 13. So I need to dimension the other side of this angle, which is a diameter of 18, so half of that is 9. And then the height of this cylinder is half of this diameter of 12, so 6. All right, so that is what that green sketch I did at the top left was supposed to look like. Now I can hit the check mark actually. And you're about to see where this magic revolve command starts to come into play. So instead of extrude, under your Boolean options, there is revolve. I select my profile, and then I select the axes it's going to revolve around. So just like that, it looks like magic, but it's basically, let me see if there's an arrow I can rotate around. I don't see one. But it's revolving around that yellow axis line. Now you can see why I did the radius and not the full sketch, because I didn't really need it. Now I'm going to hit the check mark. So there are a couple other details that I need to place. Let's go ahead and approach this back one. I could try to sketch on the top plane looking down, but what I'm going to do is, I think it's going to be a lot easier to sketch on the very end where I see the circle of this and extrude in the depth. Then I can just put a hole on top of that. I'm going to do the same thing for this front and for these holes. So a couple more steps than what you could probably get away with, but it's just going to be easier to do it this way. I'm going to rotate around the back. Let's just go to the left side view and create a sketch right on this back circle. So if you were looking at a 3D view, I'm sketching right on this plane. I'm just going to draw a line straight across. You want to make sure it's horizontally constrained and it's also coincident to either side of my circle. You don't want to go across the middle because it's not there. Now I'm going to dimension it from the top. It says it is 6 down, so I can say from here to the top of my circle, 6 millimeters. Check mark, and I'm just going to go ahead and extrude this in now. So it's cutting into my model. So I hit remove. Let's see how far it's going in. It's going in 30. Pretty close. So now there's that flat spot. Let's go ahead and do the end here. And this time, if you look at this model, there's a flat spot, but then also a rectangle coming down. So I might use a center point rectangle so it's perfectly center for the vertical. That one's comes down 3. And then I'm going to grab my center point rectangle, so that way it's symmetrical. And I'll just overdraw it because it doesn't really matter. It is too wide. So it gets me, it saves me from dimensioning from the center point. I can just dimension the width because I know it's mirrored. Alright, so now I can extrude this in. Looks like I have 2 different depths for this, so that's 2 different extrudes. Let's go ahead and do the flat surface back first because it's further back. It goes back 50. Flip directions, remove, 50. Reveal that sketch. And now I can extrude the saw curve, which goes back 32. Alright, I'm done with that sketch. Let's put the hole on the surface. I'll just do another sketch. There are hole commands, but I think it's easier to draw the circle. So I'm going to center. Basically, it's locking onto that center, which is a good thing because it's right in the middle. It is a 6mm diameter and it goes in 14, 12 off the back. So I first have to dimension from this back surface, 12. I constrained it to the center vertically when I hovered over it. So now I need to dimension the diameter of it, which again is 6. And that's all I need for the sketch. Now I can extrude it going down into the material, so cutting or removing 14. Not all the way through. Now I'm going to put the circles on this cylinder. So I'm going to create a sketch. I'll just put it right here. And I'm going to start by just placing one of the circles. So let's rotate around. The diameter of those small circles are 6. And I could place a circle where they belong, or I could just dimension half of 46 from the center. So that is going to be 23. Let's try that once I already have it extruded. Through the 12. And I need to change it to remove. I'm going to do a 3D circular pattern now. The axes of the pattern is the circle. And I want 4, and I want them to go 360 degrees, equally spaced. Done. The last thing is this chamfer. So next to fillet, there's chamfer. I'm going to select these two small edges, and the distance is 1 millimeter, and it's going to be equal from in both directions, basically meaning it's a 45 degree. As you can see, small little angled plane right off the tip. All right, let me just double check the directions. Looks like I've got everything. So I'm going to go to isometric, screenshot, and submit.